In the previous lecture, we created our purlin noise and we got it quite nicely aligned, but there are still a few seam issues that you'll come up against. So you can see a seam in my terrain that has appeared here, and we want to kind of stitch them up. The easiest way to do that is to find all these edges and actually match their heights exactly, rather than rely on the height calculations, which are going to have your integer and float rounding errors in them. Okay, so how do we actually do that? Well, remember that each terrain has a top, a bottom, a left and a right neighbor. So what we're going to do is actually ask each terrain to set its neighbor's edges to be the same as whatever its edges are. Now, we don't want every single terrain to set the edges of everybody, because then if you do like these edges for this terrain, then you've already done this edge. So when you come to this terrain and stitch around the edges, which would only be this one here, it's already been done. So rather than do that, we just ask each terrain to stitch along two of its edges. So say in this case the top one there and then the right one here, so that when this terrain did the top one here and right one here, this one would have already been done, and this terrain here would have already done this top seam, which would have joined those together. So we only need to consider two particular cases. Right, so how are we going to do this? Let's go back into our code. The first thing we need to consider is that you can't fix any of the seams until all of the terrains have been processed, because you don't know what the next seams are going to be. So therefore we're going to create another for loop here, doing exactly the same thing and going through all of our terrains. So for each terrain, terrain in, terrain.active terrains, then within here we're going to get the terrain data. So terrain data is the terrain data equals terrain data for the current terrain dot terrain data. Okay, we then need to get hold of our height map. Now we can't set this to 0 because we've already put values into it, so we actually need to use our get heights. So float a two-dimensional array, and let's call that this height map equals terrain data dot get heights from 0, 0 to the HMR. Now I'm not setting this in here, right, and we need our HMR value, which is up here, so let's just grab that. Make sure that we declare it inside of there again. Okay, so with that done, with our new height map, we're going to first of all look at the top neighbor, and we're going to set the top neighbor to basically the top seam of the terrain that we're working with, and we're going to set there the neighbor's bottom seam. Okay, so for this we first of all ask our terrain if it actually has a top neighbor, because otherwise we don't want to do it. So if terrain dot top neighbor does not equal null, then we can actually set this value. Okay, and I have to remember to use American spelling for neighbor. So if that, then we're going to go float top neighbor height map equals terrain dot top neighbor dot terrain data dot get heights 0, 0 HMR, and then for int z equals 0, so we're going to set it in the, or loop through the z coordinate values. Z is less than HMR plus Z, and then in here we'll go top neighbor height map at 0, Z is going to equal this height map value at what? Okay, this is a challenge to you. What value do you need to put into here to get the top seam of your height map into the bottom seam of its top neighbor, moving along in the Z direction? So pause the video now, give it a go, and when we come back, I'll let you know what it is. Welcome back. How did you go with that? It's a little bit tricky to figure out the math, but if we have a look at this particular value, then at the top, it's going to be HMR minus 1, because that is our X value at the top of our map. That's considering that X in this case is going up the screen, and then the Z coordinate across that way. Now we go minus 1 because of, remember, the size of the height map. We're starting at 0 here. Okay, so now that we've done that, we can then set the value down here. So terrain dot top neighbor dot terrain data dot set heights 0 0 top neighbor height map, just like that. Okay, so that's our top neighbor. The next neighbor we're going to do is our right neighbor. So if terrain dot right neighbor is not equal null, we're going to do the whole thing again, but using X values instead of Z values to transition across it. Okay, now I'm not going to pause for a long time for you to do a challenge, but if you did want to figure out this by yourself, just pause the video right now and go ahead with that. All right, so let's continue. So float array, and this time we'll call it our right neighbor height map, and that's going to equal terrain dot right neighbor dot terrain data dot get heights 0 0, and then our HMR value like that. Then we do our little for loop. This time we're going to loop around X. So X equals 0, X is less than HMR, and then we plus plus X, and then inside of here it will be our right neighbor height map at value X 0 equals this height map at X height map resolution minus 1. Okay, and then after we've done that, we just set it. So terrain dot right neighbor dot terrain data dot set heights 0 0 right neighbor height map. Okay, so that will actually set those seams for you. Let's save it, switch back into Unity, and take a look at what we get once this loads. And if you've got really nasty looking seams from your Perlin noise, you will find that they do sort of merge into each other, which you can see there. So you can see how that seam has now disappeared because those vertices are exactly the same place. Now, as I said, it might not work perfectly for all of the seams, but it is pretty good. The only way to really get it perfectly would be to overlap or join these terrains as an actual mesh, which is not what we're working towards here. Okay, so now that we've done that, you might find that there's one tiny little last issue that we need to deal with, and I can see it very clearly in this particular terrain because of the Perlin noise values that I've used. Now, this seam here, lovely. This one here is a little bit of a bump, but still it's very continuous. Have a look at this seam. What on earth is going on with this particular seam here? Well, the issue is that Perlin noise, when you use it, mirrors itself around 0, 0, 0. So at somewhere in your scene, you're going to have 0, 0, 0. Now, because this is the initial terrain, 0, 0 is probably here or there, and so therefore you see this seam, and the same thing's going on actually over here as well for 0 going in the X direction, that you can see that that seam is mirrored around there. Okay, so it bumps, and that's just what the Perlin noise algorithm does. It mirrors around 0, 0. That means our Perlin noise offset, we need to move it a lot. Okay, so we kind of want 0, 0 to be like over here, and then start calculating the Perlin from there, so that the 0, 0 has got nothing to do with our terrain. If you've taken my Voxel Minecraft course, we also get this issue that arises when our world map actually ends up around 0, 0. Everything is just reflected. Okay, so how do we do this? Well, we need to add in another little tweak to fix up that offset. We'll come and do that in the next video.